Welcome to Engineering Practical Lab. This time around, we want to talk about PN Junction Diode. And this diode is a two-terminal semiconductor device formed by joining two semiconductor materials, P-type and N-type, and it allows current to flow in one direction. So we'll look at that definition and describe what a PN junction diode is. It has two semiconductor materials, P-type and N-type, and it allows current to flow in one direction. So that two terminal is the positive, it has positive and negative. The positive is anode. This is positive terminal. And this is the symbol of PN junction diode. This symbol. It has two terminal, anode and cathode. Anode is positive terminal. Cathode is negative terminal. This is positive and this is negative terminal. So it is formed by joining two semiconductor materials together to allow current to flow in one direction. Before current will flow, there must be movement of electron and O. There must be diffusion between electron and O. Electron and O, there must be, when you say O and electron, before we can have current, before there will be flow of current. So there must be movement of electron and O, they must move together. And we have these two materials, we have a material that have these two. We have P material, semiconductor material P type. It has a lot of O, but the efficiency of electron does not have electron. Though it has electron, but that electron is minor. That's why we call it carrier. The major carrier in this P type is O. Minor carrier is electron. Likewise, this N type, the major carrier is electron. Minor carrier is O. It means that this one will have enough electron, enough O, but no electron, little or no electron. The N-type semiconductor material have a lot of electron, but little or no O. And before we can say current flow, there must be movement. Both O and electron must diffuse. They must move together because the electron will move through the O. So for this junction diode for the current to flow, there must be movement of electron and the O. They must mix together before there will be flow of electron. And when electron flow, current will flow. By the time we power a PN diode, when we put voltage source to a PN diode, it will be in two conditions: forward bias and reverse bias. So in forward bias condition, when we say forward bias of a diode, forward bias condition of a diode, it means, let's say this is our battery or voltage source, either battery or voltage source. And battery normally have positive terminal and negative terminal. So if you want to power this diode now, when you connect positive terminal of the battery, by the time we connect it with positive terminal of the diode, which is anode, when we join them together, then we connect negative terminal of the battery to negative terminal of the diode, which is cathode. That's forward bias. Forward bias. If such a thing happen, the voltage will pass through the terminal, thereby it will now break down the junction of PN diode. This junction can also be referred to as depletion region. Is an insulator that insulate the electron and the hole and make them not to come together. But by the time we have voltage source is being applied, that voltage will break down the region. It will break down the depletion region. In that case, the O will move near to the junction, electron will move near to the junction. Thereby, they will diffuse. When they diffuse, once electron flow, there will be flow of current, because movement of electron in O is what gives us electric current. In that case, by the time we forward bias a diode, PN diode, current flow. That's forward bias. Connection of positive terminal to the positive terminal of the diode, negative terminal of the battery or voltage source to negative terminal of the diode, and the current will flow. That's forward bias of a diode. It means that PN junction diode will allow current to flow in forward bias condition. Let's now look at reverse bias. When we say reverse bias of a diode, it means we connect positive terminal of the battery of the voltage source to the cathode, negative of the diode. We now connect negative of the battery to positive of the diode. That's anode. That's what we call reverse bias. Interchange the terminal of both the voltage source of the battery and the diode. You connect negative to the positive, positive of the source to the negative. That's reverse bias. In that case, it will widen the junction and it will make the division junction to be more wider. In that case, it will not enable the electron and the hole to move closer. In such a case, the electron will not be able to move and current will not flow. It means that PN junction will not allow current to flow in reverse bias condition. It will only allow current to flow in what? In forward bias condition. So that movement of flow of current in one, that's what make current to flow in one direction. This PN junction will allow current to flow in one direction in forward bias condition. So, and that's what make it useful for our rectifier. So we normally use it for rectification. That's the major application of PN junction diode, rectification. That's why sometimes they normally call it rectifier diode. So people call it rectifier diode. Rectifier diode, that's another name. Because rectifier is a circuit or electric or equipment used to convert AC to DC. We use it to convert alternate current to direct current. That's rectifier. And because in most of our rectifier circuit, so we normally use PN diode for it because it allows current to flow in one direction in forward bias condition. So they now give it a rectifier circuit, rectifier diode. That's why other name for PN junction diode is what? Rectifier diode, because it allows current to flow in one direction when you forward bias it. It will block the flow of current when you reverse bias it. But in reverse bias condition, it operates like a switch in reverse bias because it will block flow of current. But in forward bias, they use it as a rectifier because it will allow current to flow in only one direction. That's about PN junction diode, forward bias condition and reverse bias. There are two materials that you normally use to construct semiconductor, this PN junction diode. So we have silicon and germanium. They can use silicon as semiconductor material or they can use germanium as semiconductor materials. But when silicon is being used as semiconductor materials, so the voltage that normally allow the current to start flowing, so is 0.7 voltage. We call it forward voltage. For PN junction diode, the silicon materials will start conduction at 0.7 volt. The forward voltage will start from 0.7 volt. But if it is germanium materials they use to construct that PN junction diode, conduction will start at 0.3 volt. The forward voltage, the voltage at which the diode will start conduct will be 0.3 volt. That's very important for us to know. So if it's silicon materials, the forward voltage will be 0.7 volt. If it's germanium materials, it will be the forward voltage will be 0.3 volt. That is, silicon material will start conduction at 0.3 volt. Germanium material of PN junction diode will start conduction at 0.3 volt. Now let's look at the two conditions that we can find a PN junction diode, either in forward bias condition or reverse bias condition. At forward bias condition, it's going to have low resistance. Resistance will be very low. Then there is going to be high current, and that will cause conductivity. It will enable the current to flow. Then in that situation, we use it for rectification. We use it as a rectifier because it will allow current to flow in one direction in forward bias condition. Those are the characteristics of PN junction diode in forward bias condition. But in reverse bias condition, there will be high resistance. Reverse resistance will be very high. Forward resistance will be very low. Reverse resistance will be very high. So reverse current will be very low. So in that case, it will block the flow of current. It can act as a switch. It will off the electric current. Electric current will be able to flow. So in that case, it means that at forward bias condition, there's going to be high resistance value. At low resistance value, at forward bias condition, high current will occur. But at reverse bias, there will be high resistance value. So and low current will occur. The current will not be able to flow. So those are the two conditions of PN diode. High forward resistance, low forward resistance, low forward resistance, high reverse resistance, low forward resistance, high reverse resistance. Let's look at the PN diode. This is PN diode. This is how it look like. PN diode. This is how it look like. This is it. You can see that if you look at it very well, this side have a white strip, is marked with white strip. So that marked side is negative, is cathode. The unmarked side is anode, positive. This is negative, this is positive. So any marked side, this marked side, white strip. We have some other one that they are not marked with white strip, but it's being chopped off. Look at this one now. It's not marked with white strip, but it is being chopped off here. So this marked side is negative, that's cathode. This is anode. It means that in any PN diode, any marked side is cathode, is negative. Unmarked side is anode, which is positive. We have to note that. Any marked side of a PN junction diode is cathode, negative. The unmarked side is negative. So because unmarked side is positive, because there are some PN diode that they will not mark it and they will just write C or K. Anywhere you see K or C, that side marked C or K is negative, is cathode. It means that this is the negative terminal, this is the positive terminal. This is positive, this is the negative marked side, negative terminal. This is the positive, the unmarked side is positive terminal. Even the one marked with white strip, the same thing. This is negative terminal, this is the cathode, this is anode, this is negative, this is the positive. Unmarked side is positive. So this is bigger one. So we still have some smaller one. So like this. This one is smaller cathode. And this is anode positive, cathode negative. Let's now look at the application of PN diode. Application. The first one and the common one is rectification. That's rectifier. Anywhere you see rectifier circuit. So the common diode used is PN diode to convert AC to DC. Any circuit designed to convert alternate current to direct current, which is rectifier, so you must have a PN diode junction. It's what they normally use to build or to construct that circuit, to design a circuit for rectifier. You can use that as a switching circuit as well to on and off a signal. So we use it also for logic circuit. So it's also part of component that used to design logic circuit like AND gate, OR gate, NOR gate, NAND gate, and so on. It's used to design logic circuit. So when we are talking about logic circuit, so it's one of the electronic components that we normally use to design a gate like AND gate, OR gate, and other logic circuit. Let's look at the graph of PN diode, VI characteristic of PN diode, voltage current characteristic of PN diode, the graph of it. So you have this side to be forward bias condition, this side to be reverse bias condition. Then you have the current on vertical line and you have voltage on horizontal axis. When you forward bias a diode, the current will, when you continue increasing the voltage, so current will not flow until a particular forward voltage or cutting voltage. That's what we say. If it is silver, by the time it reaches 0.7, conduction will start. At 0.1, 0.2, 0.3, conduction might not start. But by the time it reaches 0.7 or almost 0.7, so the conduction will start. That's the forward current will set in and to start conduction. But if it is germanium, by the time it reaches 0.3 volt, it will start, conduction will start. And this is the forward current. Forward current will move up like this. So then look at, we have a reverse current here. These are the forward current, reverse current, forward voltage, and then reverse voltage at here. But when you reverse bias a PN junction diode, when you increasing the reverse voltage, so at a particular point the current will not flow. But there will be a point at which you'll be having small current flowing. That one is called leakage current. that current will be small, or it might not even be able to power our component, or to light our maybe a light, or maybe a bulb or a LED. It might not be enough to light up, but there will be current flowing. That one is called leakage current. When you reverse bias a diode and you are seeing some small current, that one is called leakage current. And if you continue increasing the voltage, if you continue increasing at a particular point, the current will now, there will be full current, and that current is called reverse breakdown voltage. So the voltage that make PN diode to start conduction, though it's in reverse bias, we don't expect it to, we don't expect current to flow. But at a particular point, when you reverse bias a diode, you continue increasing the voltage, reverse voltage. Then we now discover that there is current. That point at which the PN started conduction is called reverse breakdown voltage. And if you continue increasing the voltage, what will happen is that diode will be damaged. It's going to damage, that diode is going to burn. And that point is called, all this value from here down here is called breakdown region. That is the region at which, when you continue increasing voltage of a PN diode at reverse bias condition, such diode will just get burnt. That's what we call breakdown region. And the voltage that can burn the PN diode at reverse bias condition is called reverse breakdown voltage. The reverse bias voltage that can burn the PN diode is called reverse breakdown voltage. At reverse bias condition, the voltage that can damage PN diode is called what? Reverse breakdown voltage, because we don't expect current to flow in reverse bias condition. But if we now continue increasing our voltage, so there will be breakdown. So it's supposed to move in forward bias, not in reverse bias. And in reverse bias as well, we might have current. That one is called leakage current. But if now we're not having too much voltage, there will be breakdown. And that voltage is called reverse breakdown voltage. If you want to know more about this PN junction diode, go to the description of this video. So you see note there. Click on the link, download the note. Thank you.